Hello all, welcome back to our channel from Open Fen Innovation Lab, Bangalore. Today we'll work something with related to images. So for a change, instead of talking, we'll do some small basic 10-minute exercise using Python programming language. So what is the topic today? So given a set of images, you want to extract some useful information or you want to enhance the image. What is the method to be followed? Yes, it is image processing. So, coming to convolution neural network, it will eliminate the need for manual feature extraction since everything is learned through data itself. So, I can say convolution neural network provides very powerful image processing algorithms. So, we'll see what we can offer this week.
So we'll start with the hands-on session of in Python programming for image processing. So if you have installed Jupyter Notebook, it's fine. Else we can start directly. We'll use Google Collaboratory this time. Just open your browser. Here I'm using Mozilla Firefox. If you want to use Chrome, you can use Chrome as well. Just type Google Colab. So here you see, welcome to Collaboratory. Just click on that. So if you get something like this, just go with new notebook. Here, you can type any name. It will be saved in the IPYNB format. So here you can rename your notebook and all these notebooks will be saved in your particular drive, Google Drive. So to execute any program, just use the keys Shift Enter or click on this run cell, or else you can just go to runtime and run. So here my run type, I'm going to set it to be none itself. If you are going to use any kind of GPU or DPU, you can set it and give and save. So especially if you are working with CNNs like convolutional neural networks and all, this graphical processing unit can be used. As of now, for the basic exercises, we don't require any hardware accelerator as such.
So to start with the program, I am going to use this wget command. So each and every time, rather than uploading a new image file, I'll directly use this wget command followed by the URL. So what it is, so this wget is a networking command line tool that lets you download files and interact with the REST APIs. It usually supports HTTP, HTTPS, FTP and FTPS internet protocols. It also deals with unstable and slow network connections. So in the event of a download failure, it keeps trying until the entire file has been retrieved. So here you can see the URL I have entered. So you can use any URL of your choice for the image you want to work with. So in order to work with the basic image processing exercises today, we have to import certain libraries for that. So we'll discuss in brief what are they. The first one what you see is called as PIL, means Python Imaging Library, also known as Pillow. It adds image processing capabilities to our Python interpreter. This image library is designed for fast access to the data stored in a few basic pixel format. It provides an extensive file support and powerful image processing capabilities. Then what you see is Numpy. It's a library to support large multi-dimensional arrays and matrices. Means whatever image we upload, it will always be in the form of matrices and arrays, rows and columns. That's why we are going to use for Numpy. And the other one is OS. This is operating system interface. So this module provides operating system dependent functionality like reading or writing a file, manipulating the path, read all lines in the files, creation of temporary files and directories. Next, what you see here is matplot library. So this is a comprehensive plotting library for creating static, animated and interactive visualizations in Python. This matplotlib.py PyPlot is a collection of functions that make Matplot work like MATLAB. And here comes the CV2, which is a OpenCV package for Python. It is designed to solve computer vision problems. Then random. This Python import random module defines a series of functions for generating or manipulating random integers. And what we see with this CV2_im show, it is a method to display an image in a window. Window automatically fits to the large image size. And then comes TQDM. So this is a library in Python which is used for creating progress bars. So when working with OpenCV Python, images are stored in arrays. To get the dimensions of the image such as width or column or height, which are in terms of row, number of channels for each pixel, we use dot shape. Dot resize returns resized copy of the original image. So here we have written certain lines of command to do the resizing. So here you can see the resized image. I have made it to be in terms of 200 in rows and 200 in columns. So I have resized the entire image. Now we'll work on some edge detection algorithm. So for that we are using cv2.canny. So this goes through each stages such as noise reduction, finding intensity gradient of the image, non-maximum suppression, hysteresis thresholding. So why noise reduction in the sense, since edge detection is susceptible to noise in the images, and for non-maximum suppression, so having gradient magnitude and direction, a full scan image is done to remove any unwanted pixel which may not constitute the edge. So here we consider minimum value and maximum value. For minimum value, it is usually understood that they are all non-edges, and for maximum value, they are all considered to be edges. And coming to hysteresis thresholding, decision whether they are edges or not is understood here. It also removes small pixel noises based on the assumptions that edges are long. So now we'll do image cropping. So do you remember the beginning part? We used Numpy module here. Numpy package was imported. So why? Because image cropping follows the same method as Numpy array slicing. So usually the first dimension is always the number of rows and second dimension is usually with columns. So whatever the cropping command we use here, what you say with this 300, 600, 400, 900 we have given. Here it is the start row and this is the ending row, and here is the starting column and the ending column. So the first dimension and second dimension. So here in the first dimension is of rows, number of rows, and second dimension is of number of columns. So after cropping of the image is done, you can see only certain part of the image can be seen here. So this is our cropped image. Next we are going to use normalize. So it is a process in which we modify the intensity value of pixel in a given image to make the image more appealing to the senses. So it is used to increase the contrast of the image that helps in better extraction of features from image and remove the noise. So for the normalize, we usually use the parameters such as source array, destination array, alpha, beta and normalization type. So now you can see after normalization how the features have been enhanced and how more visually appealing it is. Hope this small tutorial was helpful for you all to start your journey with image processing using Python. You want to have a full code, just look at the description. I have provided my GitHub link here. I want to wish you all a very happy and prosperous Deepavali. Hope this festival brings you a lot of peace and prosperity. We post new content every week. Stay tuned to this channel. Signing off.